In order for our team to effectively and easily present our presentation, we used an outline concerning the engineering design cycle. We will first identify the problem and its constraints, then search for a solution and finalize our idea. Then we will go into how to create a drawing by using modeling software, and then show you and elaborate on the construction process and verification process.
Our main objective was to find a way to drop a quarter in a cup using 3 or more different simple machines to make one elaborate machine. The machine had to have at least 3 different simple machines. Once the machine started, it had to be able to run with no human intervention, and a new run needed to start within 10 seconds of the last one. Also, the machine couldn't be longer than 2 feet wide, 3 feet long, and 3 feet high. Once we were assigned our project teams, we constructed a team contract. We assigned ourselves different roles to assemble our design team. Samuel Lewis was our team manager, Miguel Magloire was our team designer, Carson Hanna was in charge of gathering materials, and Taylor Bauck was the team modeler.
Knowing that gravity would be the main source of energy driving our machine, we immediately began to brainstorm ideas that involved multiple inclined planes and tubes. We planned to use gravity to our greatest advantage in not only causing the ball to move, but to tip levers and move wedges. While developing our machine, we noticed that some of the machines we chose to use would not be as concordant as the rest. After some revision of our earlier designs, we modified the machines that were the most complex into simpler machines that did the same job, but would be more reliable and consistent. As a team, we found that a more simple machine that was constructed well and precisely designed for efficiency would be more consistent than a complex machine that looked impressive but had flaws. Using this design system, we were able to construct a machine that would work every time and unquestionably fulfill the task of dropping a quarter into a cup.
In order for our group to effectively and appropriately document our solution, we used a software called Autodesk Inventor Professional 2012, which helped us dimension and model our product and idea. As you can see here, our pulley was constructed and designed and modeled by creating a circle sketch with 1 inch diameter, finishing and extruding it about 0.5 thickness. Then later we created an arc 2D sketch and then rotated around an axis and did a cut extrusion. The 2 sides were then 2 2D circle sketches that were later extruded with minimal thickness. Extruding means just making it into a 3D, as you can tell. And then later, the center hole was made by creating a small circle on a 2D sketch and later doing a cut extrusion throughout the whole part. As you can see here as well, we show our inclined plane and an orbital view in exactly each facet of the product. Autodesk also helps in creating working drawings in order to put dimensions on them that could later be used in manufacturing in order to create an effective and accurate product.
To start off, we assembled a base of 2 wooden pieces, one 2 feet by 3 feet and the other 3 feet by 3 feet. Once this was accomplished, we were able to attach our 3 different simple machines, the inclined plane, a lever, and a pulley. After we positioned the machines where they were designed to be, we fastened them with screws, glue, and duct tape. In order to verify and evaluate the machine, we dropped a ball bearing into the strategically placed funnel that dropped the bearing onto the first inclined plane. The ball then rolled about 24 inches into clear plumbing tubing that was wrapped in a semicircular position and shot the ball bearing into a cup placed on top of a lever. The lever was displaced on the other side with exactly 18 cents, 3 nickels and 3 pennies, and the bearing made the lever tip. With a slot on the other side of the cup, the ball would fall into another inclined plane. At the end of the second inclined plane, the bearing made its way into a bucket, which then pulled the string fastened on a pulley which was attached to the end of a quarter dispensing lever, thus making the quarter roll into a cup effectively.
To conclude our project, remember that we solved our problem with 3 different machines that we used multiple times: inclined plane, a lever, and a pulley. We also modeled and designed our product by using a software called Autodesk Inventor Professional 2012. And then finally, we constructed our machine with wood, PVC piping, and malleable plumbing tubing, as well as other materials that were helpful to us. Thank you.